So to be able to do the difference of two squares, you have to know your perfect square roots. All right. So I'm assuming from middle school, anything that is numbers probably less than 144, you ought to be good with. All right. You can do them in your head. The numbers are not going to be too big. So in other words, if I ask you what the square root of 81 is, all right, everybody knows that's 9. All right, because 9 times 9 is 81. All right, so perfect square roots. We have to have numbers that are perfect square roots to do the difference of two squares. Okay, so let's go down. So if I had a square root of 64, then we all know that's going to be an 8. Okay, if I had square root of 9, then that's going to be 3. Okay, so you have to know all your perfect squares. All right, now you also have to know perfect square roots that have variables and exponents. Okay, so if it is an even exponent, it's a perfect square root. So if I had an x to the 4th, that 4 is even. So that is a perfect square root, and it's going to be x squared. All right, it turns out to be half every time, because later on, which we may get to the radical chapter and do a bunch of radicals, so then you'll learn this. All right, but a square root has a little imaginary 2 that sits right there. We never write it, but it's there. And if I want to find out if I can have a perfect square here, I'm going to take 4 divided by 2, and I get 2. So that's why it's always half. All right, so then if I had the square root of an x to the 10th, all right, well, 10 divided by 2, that's going to be an x to the 5th. Any even exponent will give me a perfect square root. Okay, so if I did square root of x to the 18th, all right, 18 divided by 2 is 9, so that is x to the 9th. All right. So I'm pretty sure with this just being algebra 1, you're not going to deal with any odd exponents. Okay, so you don't have to worry about that. They're going to give you ones that are perfect squares. All right, so that's just kind of a review. You have to know that before you can do difference of two squares. Okay, now I'm going to actually write the formula down for the difference of two squares. All right, so if you're looking in your algebra book, or you're looking pretty much in any algebra book, you're going to probably see it written as a squared minus b squared equals an a plus a b times an a minus a b. Okay, so I do want you to kind of get used to formulas and being able to read them. The fact that I used capital letters has no bearing on this. All right, just in the particular book I copied this out of, it had capital letters. I think in your book it uses small letters, but again, it doesn't matter whether it's capital or small here. All right, now the word difference means subtract. All right, so notice that there is a subtraction sign there. I cannot factor this way if that is not a minus sign. Okay, if that's a plus sign, you can't factor it. But as long as it's a minus sign, we can. Now, the way that this is written, a squared and b squared, what that's trying to tell you is that that number as well as that number is a perfect square root. Let's even do it like that, because both of them are perfect square roots. All right, so this would be a number like 25. This would be 36. This could be 81. All right, these then, since I just have an a over here, is what you get when you take the root. All right, so this is the root. All right, and this is the root. Okay, so just kind of explaining what and why that formula is the way it is. Okay, all right, so let's start with like really simple examples, because they're all actually going to be really simple here. So let's suppose I had something like a 9x squared minus 100. All right, every one of these, for it to be a difference of two squares, I have to have two terms, and I have to have a minus. So first of all, you check to see, do I have two terms and do I have a minus? Yes, I do, so it checks. Now, is this a perfect square root? So in other words, can I take the square root of this? Yes, I can. I am going to write this. You won't write this over here, but just on this first example, I'm going to. Can I do the square root of 9x squared? All right, well, square root of 9 is 3. Square root of the x squared is x. So I can take a perfect square root of that. And then can I take the perfect square root of 100? Yep, I get 10. All right, so then in other words, this is my a, and this is my b. So when I take the square root of those, I write both of those answers with a plus. I write both of those answers with a minus. All right, so I'm going to write 3x plus the 10, and then I'm going to write 3x minus 10. All right, and for the most part, that's all there is to this. You take the square root of the first one, you take the square root of the second one, you're writing with a plus, you're writing with a minus. Okay, now if I wanted to, like we were doing on Tuesday, we FOILed it back out. All right, if I checked this and FOILed it back out, I would get 9x squared minus 100. All right, generally these are so easy that like we don't check them, but you're more than welcome to check them. Okay, let's see. We'll just keep, like, how many of these can we do? We can do lots of them. Let's say we had a 36. Let's go x to the 4th minus 49. Let's do that one. All right, now can we do this in our head? All right, what's the square root of this? 6x squared. What's the square root of this? 7. All right, so I write 6x squared, and then I write it with a plus. Square root of this one, 7. All right, then I write the exact same thing with minus sign. So 6x squared minus 7. Okay. Are we good? Someone give me a verbal, yeah, we're good. Or no, we're not good.
We're good.
We're good? This is kind of easy so far. Okay, now, remember how on Tuesday I told you you could take a factoring thing that we had done previously and do it first and then maybe another factoring technique? All right, so this might be a factor completely. Directions might say factor completely. All right, you could possibly have something that would look like an 8x squared minus a 50. Okay, now when I first look at this, yes, I have two terms. Yes, I have a minus, but I can't take square root of 50. I can't take square root of 8. All right, but on whatever day it was it Monday, we did greatest common factor. All right, these are both even numbers. So can I take a greatest common factor out? All right, if I take a greatest common factor out, it would have to be biggest number that goes into both of those would be 2. All right, so if I take out a greatest common factor first, 8 divided by 2 gives me a 4. The x squared would stay. 50 divided by 2 is 25. All right, now, like we had done earlier, this 2 just kind of hangs out in the problem. I look at this inside part, 2 terms, it's a minus sign. 4x squared is a perfect square. 25 is a perfect square. So now I can do the difference of 2 squares right here. I keep my 2. I take the square root of the first one, which is 2x. I write it with a plus sign of whatever the square root of the second one is, which is a 5. And then once I have that, I write it again with a minus. Okay, so that is how we're going to just keep building in this chapter. We're going to just keep adding different types of factoring techniques to each problem. Okay, let's see if we can come up with another one. Let's do like a 28x squared minus 7y. Let's do y to the 4th. All right, nothing says I can't throw more than one letter in there. Okay, I have 2 terms. I do have a minus sign, so it's a difference. All right, but 28 is not a perfect square root. 7 is not a perfect square root. But can I take out a greatest common factor? 7 goes into 7, 7 goes into 28. So I can take out a greatest common factor of 7. So let's pull that out and see what we got. Then we're going to have a 4x squared minus 7 comes out. I'm just going to have a y to the 4th right there. Okay, so I first take out that greatest common factor, and then I look inside and see what I've got left. I have 2 terms. That's good. I have a minus sign. That's good. All right, 4x squared. Yep, that's a perfect square. Y to the 4th. That's a perfect square. All right, so I keep the 7. I take the square root of the first one, which would be a 2x. I write it with a plus, and then I take the square root of y to the 4th. All right, how did we do that? Square root of y to the fourth is y to the, someone say it.
Second.
Second. So then I'll have a y to the second. All right, and then write it again. X squared minus y to the second. Okay, so again, I'm just doing two different factoring techniques all in the same problem. Okay, and then that's okay. Now, so far, everyone I have given you has definitely been able to be factored. All right, they will try to kind of trick you to see if you're paying attention. All right, they'll give you like a 16x squared plus 25. Okay, you're gonna, if you're not paying attention, you're gonna go, yep, I got two terms. I can take the square root of 16x squared. I can take the square root of 25. All right, and so then you might try to factor this. All right, somebody tell me why I cannot factor this one.
It's using addition.
Ooh. Yeah, Grace, go ahead. I see you.
Because it's using addition.
Yeah, because it's using addition. That right there throws this one out. Even though that's a perfect square and that's a perfect square, it's got a plus sign in there, so I cannot do it. So you would just write, cannot be factored. That's usually what we write, cannot be factored. Okay, so that's the answer to that one. That one can't be factored. I can't take out a greatest common factor. It's definitely not the difference of two squares. Okay, so here, let's go ahead, and I got room on another one here. Let's do like an x to the 7th minus a 36. Okay, so stop and think about what you got here. Do I have two terms? Yes. Do I have a minus sign? Yes. The square root of 36 is 6. I'm good there. Can I take the square root of x to the 7th? Odd number. Can I take square root? No. Okay, because they're only going to give you ones that you can take square root of. So this one, because this is not a perfect square, okay, it's not a perfect square root, then I cannot do this one. So this one cannot be factored either. Okay. Let's do one. Let's do one where maybe, because so far these have taken two factoring skills. One was greatest common factor and then difference of two squares. But there's nothing that says we can't do the difference of two squares and then the difference of two squares again. Okay, so let's try one like that. All right, let's suppose maybe I had something like an 81 x to the 4th minus a 16. Okay, two terms, yes. Minus sign, yes. I can take the square root of 81 x to the 4th. That's a perfect square. I can take square root of 16. All right, so I'm going to go ahead and do that because obviously there's no greatest common factor here or anything. So let's see, square root of that first one is going to be a 9x squared. I'm going to write it with a plus sign and then take the square root of the second one, which is a 4. All right, then I'm going to do it again. I'm going to go 9x squared minus the 4 because that's my definition of difference of two squares. Okay, now what you have to do is you just have to pay attention. If I look right here, yes, these are both perfect squares, but that's a plus. So this I cannot do anything with. But this binomial, I have two terms. I have a minus sign. That's a perfect square, and that's a perfect square. So just like I could break that first one up, I can break this one up by the difference of two squares again. This term comes straight down. So I keep the 9x squared plus the 4. All right, now I break this one up, okay? Square root of 9x squared is going to be a 3x. We write the first one with a plus, okay? Then the square root of the 4, which is the 2. And then we do it again with a minus sign. So 3x and then minus 2. All right, I look here, I look here, I look here. Can't do any more difference of two squares. So then I'm done at that point. All right, so you can do the difference of two squares 2 times. So let's write that down. Difference of two squares. And I had to do it 2 times to be able to get to the final answer. Okay, because it's going to say factor completely. They're always going to say factor completely. And then let's do one more, just because sometimes some people don't visualize this as being a perfect square root. How about if I had a 3y minus a 3 x to the 6th y to the 5th. Okay, so when you first look at this, you go, yes, I have two terms, but these are not perfect squares. So I definitely cannot just go difference of two squares. All right, but if I see and I notice I've got a 3 in there, I definitely have a greatest common factor of 3. I also have a greatest common factor of a y. So we're going to take that greatest common factor out first. Okay, so in this first step, I'm going to take out a greatest common factor. It's got to be a 3. And then what did we do a couple days ago? If it's the greatest common factor, it's going to be the least exponent. The 1 right there. So it'll be a 3y that I take out. Okay, so I'm going to take out that 3y. All right, now 3 divided by 3 is 1. Y, take out the y, there's no y's left over. So I really do need that 1 there, because if I don't, I lose a place. It's almost kind of like, remember when we factored out that greatest common factor, if there was 2 terms up here, I had to have 2 terms inside here. Okay, so if you don't put that 1 there, you're going to drop one of the terms. 3 divided by 3 is that 1. That's why I put the 1 there. Okay, now this one, 3 divided by 3 is going to be a 1 again. I don't necessarily need to do that because I have other stuff that I'm going to put there. I still have the x to the 6th. If I had 5 y's and I took 1 out, I would have 4 left over. Okay, now at that point, okay, again, that 3y out in front, nothing. I look inside here. I ask myself, do I have 2 terms? Yes. Is it a minus sign? Yes. Are they both perfect squares? Well, these are even exponents, so I can take the square root of both of these. Can I take the square root of 1? Can I take square root of 1? Is that a perfect square? Something times itself equals 1? 1? 1 times 1 is 1. The only reason I'm throwing this in here is because some people don't look at that square root of 1 and they think they can't take the square root of it. Square root of 1 is 1. Okay, so when I go to do the difference of 2 squares, okay, so now I'm going to do difference of 2 squares. All right, so we're going to keep the 3y because it's out in front. It stays put. I take the square root of the first one, so square root of 1 is 1. Then I do the plus sign. Square root of the second one would be half of those exponents. So x to the 3rd y squared. And then I write it again with a minus. Square root of the first one, minus, and then square root of the second one. And then looking at each one of these terms, I no longer have the difference of 2 squares because that's not perfect square. Okay. All right, so